I'm Scott Kazer. I'm a junior here at WRHS, and this is...
I'm Peter Nielsen, and I'm a senior here.
Alright, so what this is this is our robot for Best Robotics. Best Robotics is a national-wide competition, but we went to the state competition. We placed 13th? Yeah? 13th? We placed 13th at the state competition. It was held at Metro. It's this big deal. They build this whole game field, and there's all these bugs to collect and capture. And I mean, that was this year's theme, but they have different themes every year of things you do. So they give you parts you can take apart and put back together, and some of the parts we have to give back, but some of the parts we don't, such as the wood and the PVC pipe and the metal. But then there's the part like the brain and the controller here that Peter has that drive the robot and make the robot work. And so that is the part we have to give back. But what's really cool is that they give us all the money to do this. We don't have to pay for any of it. That's the coolest part, is that someone's really sponsoring all of this, and that, you know, we get to do this. But I mean, that's the funnest part. And getting to build it is a ton of fun. If you want to, I mean, if you're interested in that stuff, building that stuff is a ton of fun. Especially, you know, and it teaches you some important skills like time management and stuff to do, because we definitely did not time manage very well, and we definitely should have. The building stuff, and I mean, we owe a lot of support of our teachers, but it's really cool. Like, I mean, you could pick up the termite there. The termite was part of the genetically engineered bugs we had to pick up. So we built an extending arm, and there's a spindle on the side, and I mean, then we can lower the arm, and it's been a while since anyone's driven it, but you can lower the arm, and it's got hooks, and I mean, we were making like last minute modifications, but we can pick that termite up. That's a termite. It doesn't really look like a termite. Can you close the hook? But we were actually featured in the Denver Post for this. This robot was in a Denver Post article. This was on the competition, you know, was held at Metro. It was really awesome to just get to do some of this stuff. And I mean, it was really cool to just get to do this.
Talk to us, Peter. What are you trying to do?
I'm trying to lift up the termite, the little thing down there.
And what do you have to do for it? What kind of control is that based on? Why don't you show us the little controller that you're working on?
So we have the different motions are based off of these two buttons here and these two analog sticks, and the one on the left is moves it in something called tank mode or arcade mode.
What we did was a lot of C+ programming. We weren't actually the programmer. Peter did a lot of help with the programming, which is based on a little cortex there with all the lights flashing. But all the programming is done onto that, and then there's some Wi-Fi keys, which is why this is wireless, that allow it to connect. They're Wi-Fi and Bluetooth, and you do all the programming on a computer, and then it sends out the signal to your little cortex. You update it, and then you can go drive this thing. So I mean, as soon as we got wheels and a base, we were able to drive this thing within, I mean, a couple hours of starting to work on it.
All right, Peter. So show us what you can do here.
I mean, this is actually the most difficult thing to pick up. That thing weighs, I don't know, it weighs quite a bit, and the fact that we can pick it up and hold it that high with our arm extended is actually a really impressive feat in the mechanical advantages. If you look at this side here, we have mechanical advantages of different size spindles. Yeah, set it down. Yeah.
Sorry.
I think the grip tip wore off, the wheels didn't have the best traction. But, so there's these here that run through that, and that pulls that, and it gives it some serious power. And the other thing was, it wasn't so much the engineering part, it was the creative thinking. We did a lot of creative thinking, and I mean, we had a lot of help, but the creative thinking, we reinvented this at the actual competition. This used to be actually inverted, and it came up, and it was more of a hook than a claw. And we had to be able to open a door with this, as well as like grab stuff and pick stuff up. And then this had to all fit within a 2 foot by 2 foot by a 2 foot cube, and we actually were really creative about our design, and this hole here is for the arm, and the arm slips down into that hole, and then you put it inside this cube, and they have to weigh it and everything. But we built on the diagonal from here to here in each corner of the cube, giving us a lot more space to work with for the arm length, allowing us to get this really long arm. Is what we had to do was pick up this termite and move it into a box that was 1 foot wide by 3 foot long, this containment area, which was over obstacles. And so the ability to just have that longer arm was, like, to put it there, that was a really nice ability. It took a lot of thought and a lot of brainstorming kind of by everybody on the team to build it. And we could talk about it as we spent a long brainstorm period and then actually didn't build anything for a while. But the reality is we need to work on our time management. And I think that's a really important, like the two biggest things I got out of this was time management and like creative thinking. I don't know, what did you get out of it?
Definitely.
Those were,
Talk to us for a minute, Peter.
Well, yeah, out of this I got time management and creative thinking. And also, I guess adding a new type of new mindset, I guess, for programming, since this is different than a lot of the other programming languages I've
Okay.
worked with.
You guys want to say in conclusion, any other demos you want to do with it? Anything else it can do for us?
Not a whole lot. It was very specific purpose oriented for the competition that it was designed for. There was some other creative thinking, like cutting holes for the motors.
Now, within the competition, how many other schools were involved?
There were at least 24 other schools involved. 24 registered. Yeah, 24 registered teams.
All from around Colorado?
Yeah, all from, there were some Fort Collins, some Colorado Springs teams. It's you. But there were some teams from really far away, and there were also some middle schools there too, which was impressive. And we didn't do the whole best competition, but a lot of the competition, a lot of the other schools, they have this as a class, and they get to do some really cool stuff with it. And they also get to, they have to provide a notebook and a marketing presentation and talk about all this other stuff that goes with building something like this and then producing it. Because the idea was to capture genetically altered bugs that were released into a habitat, and you couldn't have humans go get them. They had to be picked up by these robots.
Oh,
And
very cool.
We built like a trap to catch some of the bugs. And we had some really creative thoughts going. We didn't get to use all of them, and I think that kind of hurt us maybe points wise. But I think it was a lot of fun when we were actually enjoying it. I know I definitely spent some time in this room laughing over really weird things late at night, the night before the competition. But it was really enjoyable, and it was a great experience, I thought.
Good.
To be able to get to do this.
All right, guys. Anything we want to say to wrap it up?
I'd like to thank Mr. Livingston, because he put in a lot of time, and Mr. Schultz as well. And both of their wives for putting up with it, and our parents as well for putting up with it. But we spent a lot of time, the 2-3 weeks up to the competition.
Good job, guys. Now for the applause. Thank you.